All right, guys, happy Wednesday. We are working on our section of notes for worksheet 3. So midpoint and distance formulas. Again, you already have this packet if you picked it up from school. You can print it off. It is posted on Canvas, or you may write on notebook paper. All of those are valid choices. So definition of midpoint. Midpoint is a point on a segment which divides a segment into two congruent segments. Congruent means that they have the same measure. Okay, so here M is our midpoint, which means that these two smaller segments now, AM and BM, are congruent. So AM is congruent, so that's an equal sign, and then we put this wave on top. This is our symbol for congruent to BM. Okay, these are equal. We only know that they're equal if they tell us it's a midpoint or if they have these tick marks. These tick marks means that these segments are the same, okay? Even if it looks like it's in the middle, we can't assume it is. They have to tell us that they're equal or that it's a midpoint. Definition of segment bisector. Segment bisector is a segment, line, ray, or plane that intersects a segment through its midpoint. Okay, so this prefix bi means two. It's sector means it's cutting through it, so it makes two equal pieces. So here our bisector is this line L. So if L bisects AB, then that tells us that AM is congruent to BM. Okay, so that's another way we can tell that this is the midpoint if they tell us that we have a segment bisector, because it has to go through the midpoint. So is this a midpoint? Explain. This, they don't tell us it's a midpoint, and they don't mark either side. And then on top of that, they just don't even look equal. This side is longer. So no, unequal. Unequal segments, we'll say. Here they tell us they're equal by using these tick marks. So yes, that would be a midpoint. And in this one, they're telling us they're equal, but it's not one line segment. It's not one straight across. They're not collinear. So no, because they're not collinear. Example 1, identify the midpoint and segment bisector of PQ. Then find PQ. So the midpoint of PQ is right here, and we know that because these are marked as the same. So our midpoint is F, just a capital F. Our segment bisector is this segment, which we can name CB. You could also name it CF or FB, but I'm going to choose CB. And then it says find PQ. So if we know that this section is 6.2, this tick mark tells us this is also 6.2, so PQ as a whole is 12.4 if you add those together. Remember, we have that segment addition postulate from yesterday. Here, our midpoint, it looks like, is M. Our segment bisector is line L. It's labeled right up here. And then to find PQ, we know these are equal, so we're going to go ahead and set up an algebraic expression where they're equal so that we can figure out what X is. So I'm going to subtract 2x from both sides. So we're going to get 3x minus 7 equals 11. Add 7 to both sides. And divide by 3 on both sides. So x is 6. So if you plug it back in, 5 times 6 is 30. 30 minus 7 is 23. This should also be 23, but if we check, 2 times 6 is 12, plus 11 is 23. So PQ all the way across is 46. Example 2, L bisects HJ at W. Since it said it bisected, we know that these two are equal, and we also know that W is the midpoint. Find the value of x and the length of the segments. So if HW is 3x, HJ all the way across is 5x plus 10. So I know that since these are equal, this one is also 3x. So I'll do 3x plus 3x equals 5x plus 10. So if I combine like terms, that's 6x. Then I'll subtract 5x from both sides. So we have x equals 10. If I plug that in, that means that each of these smaller ones are 30 across. 5 times 10 is 50, plus 10 is 60, which should make sense because 30 plus 30 is 60. All right, midpoint and distant. Okay, so when you're given the midpoint, we're going to have 2 points. We're going to have x1 and y1 and x2 and y2. If I want to find the middle of these 2 points, then, and we'll call them xm for midpoint, ym for midpoint, we have to find the average essentially. We have to find the center. So I would take x1 plus x2 and divide by 2 to find the middle. And then same for y. I would add my 2 y values together and divide by 2. Distance formula is going to help us find the distance between 2 points. So this helps us find the middle. To find the distance, we're going to use d for distance equals the square root. And then you take x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. And this actually comes from Pythagorean theorem. I don't know if you remember Pythagorean theorem or not from algebra, where you had a squared plus b squared equals c squared. This formula comes from that. So that's why it's this quantity squared plus this quantity squared equals this one squared, but instead we're doing the square root. So they really are the same. You can use Pythagorean theorem instead, but this is our distance formula. The endpoints of DT are 1, 2, and 7, 8. Use the midpoint formula to find the coordinates of the midpoint O. So these two with our red arrows are our x values. These two are our y values, and you average them. So we'll do 1 plus 7 over 2 and 2 plus 8 over 2. Okay, so that point, this would be 8 divided by 2 is 4. 10 divided by 2 is 5. So point O is 4, 5. That's your midpoint. The midpoint of DG is O at negative 1, 2. So this time we know, or negative 1, negative 2. This time we know the midpoint. One endpoint is 4, 4. What's the other endpoint? So we know we'll do 4 plus x over 2, because this is the one we're trying to find, and 4 plus y over 2. So if this is equal, this right here is equal to negative 1, we can set that up and solve. So 4 plus x over 2 equals negative 1. I'd have to multiply by 2 on both sides first. So you have 4 plus x equals negative 2, and subtract 4. So x equals negative 6. And then we'll do the same for y. So here we'll have 4 plus y over 2 equals negative 2. Multiply by 2. And then subtract 4. So in this case, y equals -8. So our endpoint G is -6, -8. You always do x and then y for a point. Example 5, find GH if G at -2, -6, and H is at 1, -2. So GH is the length of that segment, which means we're going to use our distance formula. So distance equals the square root. You're going to subtract your x's. So -2 minus 1 squared, and you're subtracting your y's, -6 minus -2 squared. The order doesn't matter as long as you're consistent. So since I started with point G, I need to start with point G both times. But I could have switched them and started with H as long as I did it both times. It won't affect your answer. So here, -2 minus 1 is -3 squared. -6 minus -2, you can add the opposite there, would be -4 squared. So this is going to be 9 plus 16, which is 25. So our distance is 5. So GH, this segment, has a length of 5. Okay? Technically, this is positive or -5 if you remember that from algebra, but we can't have a negative measurement, a negative distance. All right, last one for today. The endpoints of two segments are given. Find each segment length. Tell whether the segments are congruent. So we will do our distance formula for each and then see if they're the same. So for EF, we'll do that one here. And really, you can even type this string of things, this whole formula, into your calculator if you want. So this one would be -4 squared and 3 squared. So it's going to be essentially the same thing as up here. So then you have 16 plus 9 is 25. Square root of 25 is 5. Okay, all of these are your distance. And then we'll do the same for GH. And 1 minus 6. So this one is going to be -4 squared plus -5 squared. So 16 plus 25 is going to be 41. I'm going to go ahead and simplify that in my calculator. It is approximately 6.4. So EF is not congruent to GH. Okay, they have different lengths. They're both 5 or both approximately 6.4, then they would be. All right. Today's assignment is just like what we were doing yesterday, where you will have worksheet 3 in your packet, which is pages 18 and 19. And then you can check with the key and upload a picture into Canvas. And then you also have a section on Delta Math. So you have a paper section and an online section. Make sure you get both submitted.